wave and longitudinal stationary waves. When two identical transverse waves interfere with each other, then we get a transverse stationary wave. For example, a wave formed on the string. Similarly, when two identical longitudinal waves travels along the same path but in opposite direction, they interfere with each other to form a new pattern in the medium, which is called as the longitudinal stationary wave. Also, you have seen the difference between the transverse or stationary wave and the progressive wave. Now you see vibrations of air column in a pipe closed at one end. Vibrations of an air column in a pipe closed at one end. Before going to see this, we must know what is end correction. We see what is end correction. Suppose this is a pipe having length L, and this pipe confines the air from the outside air. That means this pipe consists of an air which is called as an air column, which forms the air column. Okay, and when a vibrating tuning fork, we know that a tuning fork produces a sound wave. When the prongs of the tuning fork vibrates outwards and inwards, then compressions and reflections are formed in the medium, and these compressions and reflections travel one after another, which forms the longitudinal wave. Such a vibrating tuning fork is held such that its prongs are perpendicular to the length of the tube or the pipe. Then the longitudinal wave travels along this tube and gets reflected from the closed end. This longitudinal wave, which is formed by the prongs of the tuning fork, this longitudinal wave travels along the length of the tube. Here there is a closed end. The wave gets reflected from the closed end. A change of phase of pi radians is produced, and therefore this air column consists of two identical longitudinal waves, incident and reflected. So there are two identical waves having the same amplitude, having the same frequency, having the same wavelength, and these are traveling along the same path but in opposite direction, which satisfies the condition for formation of the stationary wave. So stationary wave forms in this air column. That means this air column vibrates, and which creates the stationary wave in the air column. Suppose L is the length, small l. Small l is the length of an air column. Then this stationary wave forms in the medium, and we know that stationary wave consists of antinodes and nodes. Now here there is a open end, and the particles of the open end are free to vibrate, and therefore as the particles are free to vibrate, the amplitude is maximum, and where the amplitude is maximum we call as the antinode. So antinode is formed at the open end, but this is the closed end. The particles near the closed end are not free to vibrate. That is, there is a limitation on that particles to vibrate. So amplitude of vibration is very small, and therefore node is formed at the closed end and antinode is formed at the open end. Okay, so stationary wave, that is longitudinal stationary wave, forms in the air column which is closed at one end. Only boundary condition is that Antinode should be formed at the open end and node should be formed at the closed end. Okay. So the stationary wave forms like this. We show in the form of loop like this. Here is node and here is antinode. Look here, the antinode is formed just above the open end. ओपन एंड कुठे आहे? इथं ओपन एंड आहे आणि अँटीनोड कुठे निर्माण झालंय? या ओपन एंडच्या थोडंसं वरती निर्माण झालेलं आहे. कारण का? बिकॉज द पार्टिकल्स ॲट द ओपन एंड आर मोर फ्रीडम टू व्हायब्रेट. म्हणजे इथले जे पार्टिकल्स आहेत या पार्टिकलना व्हायब्रेट होण्यासाठी त्या ठिकाणी जास्त फ्रीडम आहे. तिथं फ्री आहे ते पार्टिकल आणि म्हणून तिथले पार्टिकल हे व्हायब्रेट होतात. म्हणून अँटीनोड निर्माण होताना ओपन एंडच्या थोडंसं वरती निर्माण होतं. आणि हे जे डिस्टन्स आहे हा अँटीनोड आहे. इथं ओपन एंड जर बघितलं आपण या ठिकाणी ओपन एंड आहे. दिस इज द लेंथ ऑफ द पाईप. ही पाईपची लेंथ आहे. इथं अँटीनोड निर्माण झाले. हे जे डिस्टन्स आहे, डिस्टन्स of an antinode from the open end of the tube is called as the end correction. त्याला म्हटलं जातं end correction. So what is end correction? End correction is nothing but it is the distance between the open end of the tube and the antinode. That distance is called as the end correction. याला आपण त्या ठिकाणी end correction म्हणतो. And this end correction is given by the formula E is equal to 0.3 D. End correction is given by the formula E is equal to 0.3 D. Small d. What is small d? Small d is nothing but it is the inner diameter of the tube or pipe. आपण जी पाईप घेतलेली आहे त्या पाईपचं इनर डायमीटर आहे. हा जो इनर डायमीटर आहे तो इनर डायमीटर आहे डी. आणि त्या इनर डायमीटरला आपण जर 0.3 न मल्टिप्लाय केलं तर आपल्याला त्याचं एंड करेक्शन मिळतं. ओके. सो दिस इज एंड करेक्शन. नाव करेक्ट व्हायब्रेटिंग लेंथ. आता व्हायब्रेटिंग लेंथ जी आहे ती करेक्ट व्हायब्रेटिंग लेंथ कुठून असणार? नोड टू अँटीनोड. दॅट इज कॅपिटल एल. कॅपिटल एल is the correct vibrating length. आणि correct vibrating length काय असणार आहे? Length of the tube that is small l plus end correction. म्हणजे हे जे अंतर आहे end correction. So capital L is equal to small l plus e. So this is correct vibrating length is equal to length of pipe plus end correction. So L is equal to small l plus e. So this is the end correction. Do you get it? What is end correction? End correction is nothing but it is the distance between the open end of the tube and the antinode. This distance is called as the end correction. This is in case of pipe closed at one end. If the pipe is open at both the bends, then what will be the end correction? समजा ही जर पाईप आहे, ही पाईप या बाजूला पण त्या ठिकाणी ओपन असते. Then what will be the end correction? Then stationary wave which is formed in this air column will be like this. इथं जी स्टेशनरी वेव्ह निर्माण झालेली आहे ही कशी असणार आहे? सपोज दिस मिड पॉइंट like this. Now the open end on both sides. Here also the particles have more freedom to vibrate. Here also particles have more freedom to vibrate. So antinode is formed at the open end. When the stationary wave forms, antinode always forms at the open end. But here there are two open ends. So two antinodes are formed and one node is formed. Here is also antinode, here is also antinode, and one node is formed here. Okay. Now we have to apply the end correction on this side as well as on this side. The distance between the open end of the tube and the antinode, this is also called as the end correction. म्हणजे पाईप जर त्या ठिकाणी दोन्ही बाजूला ओपन असेल तर आपल्याला एंड करेक्शन अप्लाय करत असताना दोन्ही बाजूला एंड करेक्शन अप्लाय करावं लागेल. दिस E plus E. So in this case, what will be the correct vibrating length? Correct vibrating length, that means the distance between the two antinodes, this antinode and this antinode. Length of the pipe is L. So capital L is equal to L plus what happens? This E plus this E. What happens? 2E. So if the pipe is open at both the ends, then the correct vibrating length will be L is equal to L plus 2E, because there is end correction on both the sides. So if the pipe is open at both the ends, then the end correction will be, that means end correction will be on both sides. So correct vibrating length is equal to length of pipe plus end corrections on both sides, that is 2E. So this is about the end correction. Okay. So what is end correction? End correction is nothing but it is the distance of antinode from the open end of the tube is called as the end correction. In case of pipe closed at one end correction will be only on the side which is at open end. But if the pipe is open at both ends, then end correction will be applied on both the ends. That means 2E. Okay. Now you see the vibrations of an air column in pipe closed at one end. Vibrations of an air column in a pipe closed at one end. So this will be the pipe here shown. L is the length of the pipe. Okay. And if the vibrating tuning fork is held with its prong perpendicular to the length of the tube, then the longitudinal wave will travel along the tube and gets reflected from the closed end. So there will be two identical waves traveling along the same path but in opposite direction, which forms the stationary wave. But here, as the pipe is closed at one end, there is one closed end and one open end. What is the boundary condition? There should be antinode at the open end and node should be at the closed end. So antinode should be formed at the open end, node should be formed at the closed end. So it consists of one antinode and one node. Okay. In this case also, the antinode is formed just above the open end. This distance is called as the end correction. That is called as the end correction. Okay. This is called the simplest mode of vibration. हा जो आहे व्हायब्रेशन ऑफ एअर कॉलम, म्हणजे या पाईप मध्ये जो एअर कॉलम आहे तो एअर कॉलम व्हायब्रेट होतो, त्याचा हा सगळ्यात सिम्पलेस्ट मोड आहे. म्हणजे एक नोड आणि एक अँटीनोड. दिस इज सिम्पलेस्ट. याच्यापेक्षा आपण लोएस्ट मध्ये येऊ शकत नाहीये. सो दिस इज द सिम्पलेस्ट मोड ऑफ व्हायब्रेशन ऑफ एन एअर कॉलम. इट consists of one node and one antinode. Okay. Now you know the length of one loop is lambda by 2. Suppose n is the frequency of vibration and lambda is the wavelength. याच्यामध्ये समजा n ही frequency of vibration असेल, lambda ही wavelength असेल. And length of one loop, that is distance between node to node, is lambda by 2. And distance between node and antinode is lambda by 4. Distance between node and antinode is lambda by 4. That is length of half loop is lambda by 4. We have seen in the characteristic of stationary wave. Length of one loop is lambda by 2. Here is half loop. There is not full loop. So as the distance between antinode and node is lambda by 4. So correct vibrating length here L is equal to lambda by 4. So correct vibrating length L is equal to lambda by 4 and therefore lambda is equal to, what happens, lambda is equal to 4L. आपल्याला मिळेल lambda is equal to 4L. As n is the frequency of vibration and lambda is the wavelength, then v, velocity of the wave, v is equal to n lambda. Therefore n is equal to v by lambda. As v is equal to n lambda, n is equal to v divided by lambda, and lambda is equal to 4L. So frequency of vibration n is equal to v divided by 4L. Frequency of vibration v divided by 4L. Now this is the lowest frequency of vibration of air column in case of pipe closed at 1 inch. ही सगळ्यात कमी फ्रिक्वेन्सी आहे. आपण आता पुढे बघणार आहोत की फ्रिक्वेन्सी कशी कशी वाढत जाते. ही लोएस्ट फ्रिक्वेन्सी आहे, and this frequency is lowest frequency, this is called as fundamental frequency. It is called as fundamental frequency. Also it is called as first harmonic. Remember the word. It is a first harmonic. त्याला म्हणतात फर्स्ट हार्मोनिक किंवा याला म्हणतात फंडामेंटल फ्रिक्वेन्सी. हा जो मोड आहे हा सिम्पलेस्ट मोड आहे, म्हणून याला म्हटलं जातं फंडामेंटल मोड. जी फ्रिक्वेन्सी असते त्याला म्हणायचं फंडामेंटल फ्रिक्वेन्सी, किंवा त्याला दुसरं नाव आहे फर्स्ट हार्मोनिक. त्याला फर्स्ट हार्मोनिक असं म्हणायचं. ओके, आपल्याला फक्त त्या ठिकाणी नंतर हार्मोनिक्स आणि ओव्हरटोन्स म्हणजे काय ते आपल्याला बघायचं. त्यासाठी हे लक्षात ठेवा. आता फक्त नंतर मी तुम्हाला सांगेन की हार्मोनिक्स म्हणजे काय आणि ओव्हरटोन्स म्हणजे काय. ओके, सो दिस इज द फर्स्ट मोड ऑफ व्हायब्रेशन विच इज शोन इन फिगर A. नाउ दिस फिगर B shows the next mode of vibration of air column in a pipe closed at 1 inch. आता हा वेगळा फॉर्म आहे, याच्यामध्ये वेगळ्या फॉर्म मध्ये त्या ठिकाणी व्हायब्रेट होते. त्याच्यामध्ये काय झालं, इथं एक नोड आणि इथे एक अँटी नोड होता. याच्यामध्ये परत एक नोड आणि एक अँटी नोड वाढला, म्हणजे दोन अँटी नोड आणि दोन नोड झाले. दोन अँटी नोड आणि दोन नोड झाले. मग जर या ठिकाणी आपण दोन अँटी नोड आणि दोन नोड म्हणलं, आपण हाफ लूप जर बघितलं, इथं बघितलं हाफ लूप एवढं होतं, इथं हाफ लूप एवढंच आहे फक्त. याचा अर्थ वेवलेंथ काय झाली, चेंज झाली. आणि वेवलेंथ जर चेंज झाली असेल तर फ्रिक्वेन्सी सुद्धा चेंज होते. मग ह्या बी मोड मध्ये समजा आपण म्हणलं N1 with the frequency of vibration and λ1 is the wavelength. N1 is the frequency of vibration in the mode which is shown in figure B. Here I can write B here, and λ1 is the wavelength because the wavelength is changed here. Okay, now look here, the correct vibrating length. Here we can also write in terms of end correction, we can write N is equal to V divided by 4 into small l plus e. You have taken only e here because end correction is on one side. That is one end correction. Okay, 4 into l plus e. Okay, now here λ1 is the wavelength. Now this distance node to node, as λ1 is the wavelength, this distance is λ1 by 2. λ1 by distance between nodes, length of one loop is λ1 by 2, and λ1 by 2 plus λ1 by 4. λ1 by 2 plus λ1 by 4. So correct length of vibration L is equal to 3 λ1 by 4. You can see it. λ1 by 2 plus λ1 by 4. It will be 3 λ1 by 4. Correct length of vibration. Okay. Now λ1 here we can write λ1 is equal to 4L divided by 3. Lambda 1 is equal to, हे 4 इकडे घेतलं, 4L divided by 3. So lambda 1 is equal to 4L divided by 3. Then velocity, similarly V is equal to N1 lambda 1. Frequency is N1, wavelength is lambda 1. So V is equal to N1 lambda 1. So as V is equal to N1 lambda 1, then N1 will be V divided by lambda 1. N1 is V divided by lambda 1, which is equal to, we can write V divided by lambda 1, but lambda 1 is equal to 4L divided by 3. Lambda 1 is 4L divided by 3. So N1 is equal to 3V divided by 4L. N1 is 3V divided by 4L. Now look here. V by 4L is equal to N. That is fundamental frequency, lowest frequency, which is also called as the first harmonic. Now here V by 4L is N. V by 4L is N and 3 is extra N. 3 times V by 4L. V by 4L is N. So N1 is equal to 3N. N1 is equal to 3L. In terms of end correction, we can write this as 3V divided by 4 into small l plus E. कारण एंड करेक्शन काय आहे, एकाच बाजूला आहे, त्यामुळे आपल्याला फक्त E घेता येईल. N1 is equal to 3L. And this is called as the third harmonic. It is called as the third harmonic. ही जी फ्रिक्वेन्सी आहे, ही फ्रिक्वेन्सी फंडामेंटल फ्रिक्वेन्सीच्या 3 पट जास्त आहे. फंडामेंटल फ्रिक्वेन्सीच्या 3 पट जास्त आहे, म्हणून याला म्हटलं तर थर्ड हार्मोनिक. ओके. ऑल्सो इट इज कॉल्ड एज दी फर्स्ट ओव्हरटोन. याला काय म्हटलं तर फर्स्ट ओव्हरटोन. टोन म्हणजे काय, आवाज. इट इज अ साऊंड नोट. ओव्हर म्हणजे एक्स्ट्रा, म्हणजे हा एक्स्ट्रा नोट आहे. लक्षात आलं. म्हणजे हा पहिला आहे, हा त्याच्यानंतर दुसरा आहे, म्हणजे आवाज दुसरा आहे. म्हणजे फर्स्ट ओव्हरटोन. फंडामेंटल फ्रिक्वेन्सीला ओव्हरटोन म्हणत नाही. फंडामेंटल फ्रिक्वेन्सी किंवा त्याला फर्स्ट हार्मोनिक म्हटलं जातं. इथं आहे फ्रिक्वेन्सी ही फर्स्ट हार्मोनिकच्या एनच्या 3 पट आहे, थर्ड हार्मोनिक किंवा याला म्हणतात फर्स्ट ओव्हरटोन. इट इज कॉल्ड एज दी third harmonic or first overtone. Okay, now the next mode of vibration which is shown in figure C. इथं त्या ठिकाणी पुढचा मोड दिलेला आहे, त्या ठिकाणी व्हायब्रेशनचा. नेक्स्ट मोड ऑफ व्हायब्रेशन shown in figure C. We'll see it. Now this mode of vibration consists of 2 more antinodes and 2 more nodes. इथं काय होतं, एक अँटीनोड एक नोड. इथं 2 अँटीनोड 2 नोड. आता इथं असणार 3 अँटीनोड आणि 3 नोड. बघा इथं एक अँटीनोड, दुसरा अँटीनोड, तिसरा अँटीनोड, पहिला नोड, दुसरा नोड आणि हा तिसरा नोड. So 2 more antinodes and 2 more nodes. Now look here, the length of loop इथून इथपर्यंत आहे. हे लूप किती लहान झालं, हे लूप त्याने मोठं आहे. याचा अर्थ वेवलेंथ चेंज झाली. वेवलेंथ इज चेंज्ड. सपोज, आणि वेवलेंथ जर चेंज झाली असेल तर फ्रिक्वेन्सी सुद्धा चेंज होणार. सपोज इन दिस केस फ्रॉम सी, नेक्स्ट मोड ऑफ व्हायब्रेशन, सपोज N2 be the frequency of vibration and lambda 2 be the wavelength. लॅम्बडा 2 समजा वेवलेंथ असेल आणि N2 ही फ्रिक्वेन्सी, याची फ्रिक्वेन्सी ऑफ व्हायब्रेशन असेल. ओके. नाव दिस as wavelength is lambda 2, this distance is lambda 2 by 2, half the wavelength lambda 2 by 2. So this distance is lambda 2 divided by 2. Again this distance lambda 2 divided by 2. And this distance lambda 2 divided by 4. Okay, So lambda 2 by 2, lambda 2 by 2, this is lambda 2, and lambda 2 plus lambda 2 by 4, this will be 5 lambda 2 by 4. Okay, so correct vibrating length of the air column in this mode of vibration is 5 lambda 2 by 4. So correct length of vibration L is equal to 5 lambda 2 divided by 4, and therefore lambda 2 is equal to 4L divided by 5. इतची वेवलेंथ आपल्याला मिळेल 4L divided by 5. As N2 is the frequency and lambda 2 is the wavelength, then frequency of vibration is N2, lambda 2 is the wavelength, velocity will be V is equal to N2 lambda 2, and therefore frequency of vibration N2 is equal to V divided by lambda. N2 is equal to V divided by lambda 2, but lambda 2 is equal to 4L by 5, and therefore N2 is equal to 5V divided by 4L. 5V divided by 4L. Also we can write this as 5V divided by 4 into small l plus e in terms of end correction. Instead of writing capital L, we can write small l plus e. That is length of the air column plus end correction. Okay. Now look here, N2 is equal to 5V divided by 4L. V by 4L is fundamental frequency, also called as the first harmonic. As V by 4L is N, so it is 5 times fundamental frequency. So N2 is equal to 5N. Okay, this frequency of vibration is called as fifth harmonic, also called as second overtone. याला फिफ्थ हार्मोनिक म्हणलं जातं किंवा सेकंड ओव्हरटोन म्हणलं जातं. ओके, so this frequency is 5 times of fundamental frequency, so it is called as the fifth harmonic, also called as the second overtone. हा first overtone, हा second overtone. This is fundamental frequency, also called as the first harmonic. This is the third harmonic, 3 times of fundamental frequency. This is fifth harmonic, 5 times of fundamental frequency. If we take next mode of vibration, then N3 will be 7N. This is called as the seventh harmonic or third overtone. Seventh harmonic, third overtone. त्याच्या पुढचा मिळून आपण घेतला N4. N4 is equal to 9N. This is called as the ninth harmonic or it is fourth overtone. Okay, this is third overtone, this is fourth overtone. So frequency of fifth overtone is given by generally or fifth overtone, Np is equal to 2p plus 1 into N. This is the general formula for frequency of fifth overtone. Fifth overtone. हे fifth overtone याचा अर्थ जर आपण त्या ठिकाणी p ची किंमत 1 घेतली म्हणजे पहिला ओव्हरटोन, फर्स्ट ओव्हरटोन p is equal to 1, 2 into 1 plus 1, that is 3n. So 3n is the first overtone. Okay, do you get it? Then if we take p is equal to 2, then what happens? 2 into 2 plus 1, that is 4 plus 1, that is 5n. Look here, 5n. This is called as the fifth harmonic or second overtone. It is second overtone. If we take p is equal to 2, that is second overtone. Similarly, if we take p is equal to 3, so 3 into 2, what happens? 3 into 2, 6, 6 plus 1, 7n, that is 7n. It is seventh harmonic or third overtone because we have taken p is equal to 2. So vibrations of an air column consists of fundamental frequency n, याच्यामध्ये n आहे, n is equal to v by 4l. त्याच्यानंतरची फ्रिक्वेन्सी कुठली आहे? 3n. त्याच्यानंतरची फ्रिक्वेन्सी कुठली आहे 5n. ओके, त्याच्यानंतरची 7n, त्याच्यानंतरची 9n and so on. This is first harmonic, third harmonic, fifth harmonic, seventh harmonic, ninth harmonic. आणि मग आपल्या लक्षात येतं या ठिकाणी 1, 3, 5, 7, 9 हे कसले नंबर्स आहेत? ऑड नंबर्स. हे जे आहे ते कसले आहे? ऑड नंबर्स. फर्स्ट हार्मोनिक, थर्ड हार्मोनिक, फिफ्थ हार्मोनिक, सेवन्थ हार्मोनिक, नाइन्थ हार्मोनिक and so on. So vibrations of an air column in a pipe closed at one end consists of only odd harmonics. Odd harmonics are present in a case of pipe open at one end, that is closed at one end, and even harmonics are absent. 2n याच्यामध्ये आहे का? नाही. 4n याच्यामध्ये आहे का? नाही. 6n याच्यामध्ये आहे का? नाही. म्हणजे जे इव्हन हार्मोनिक आहेत ते याच्यामध्ये असत नाही. इव्हन हार्मोनिक्स आर ॲब्सेंट इन केस ऑफ व्हायब्रेशन ऑफ पाईप क्लोज्ड ॲट वन एंड